So fine, good afternoon to you all students. Hi students, how are you? I hope you all are fine. Students, have you all enjoyed your holidays? So have you all utilized these holidays? So we have completed till chapter 7. So except chapter 2. So have you all thorough till chapter 7? Thorough or not? So today we are going to study about chapter 8. Welcome to our today's online class, students. So today we are going to study about chapter 8. Okay. So chapter 6, 7 and 8 are almost combined together. So these three chapters are fully raw theory. Okay. So already I said. So after completion of this chapter 8, so I will take chapter 2. Okay. So have you all studied till completed portions? Have you all studied or not? So please study daily's portion. Okay. So please study. So at last you will think at last we can study. So you won't get time for you to study. Please study daily's portion. Okay. So today we are going to study about chapter 8. So what's the title of our chapter means? Iteration and recursion. Okay. In this chapter we are going to study detailed about what do you mean by iteration and what do you mean by recursion. Okay. First. Okay. So what do you mean by iteration? Okay, what do you mean by iteration means? For example, take some problems in maths or in some problems you take. In some problems, we need to solve something again and again. Okay, consider you have one problem. Okay, you are going to solve one problem. Okay, in that problem, if you need to get the proper solution means some portions of the problem you need to solve again and again. For example, so in a problem, so you need to add, okay, add 2 or 3 numbers. For example, 4 places you need to add, one place you need to add 2 numbers. One place you need to add 3 numbers. In another one place you need to add 4 numbers. But the action becomes same. What's action? Adding. But the numbers becomes different. For in first place you need to add 2 numbers. In another one place you need to add 3 numbers. Some other place you need to add 4 numbers. For example only I am telling. Okay. So what I am coming to say means, so if you are going to solve a problem, some things you are going to do repeatedly or again and again. Understand? What do you mean by repeatedly? Again and again. So if you do that things or that actions again and again, then only you need to get the proper output for the problem. Okay, understand? So in a problem, so you are doing some actions again and again. For that only an example is for if you need to solve one big problem, in that problem lot of steps will be there. Some 4 places you need to add, 3 places you need to subtract, some places you need to multiply. Likewise, what's the action you are doing there? Addition means addition. Subtraction means subtraction. Multiplication means multiplication. But that thing you are doing again and again or repeatedly to get the proper answer for that problem. Understand? So that process only we are calling as an iteration. Understand what I mean by iteration? So some problems you need to solve by doing the same action again and again. So that process we are calling as an what? Iteration. Okay. So in this chapter you are going to study about 2 techniques. Okay. What's the title of our chapter? Iteration and recursion. Okay. So both this iteration as well as recursion are algorithm design techniques. Okay. Both this iteration and recursion are what design techniques? This is also algorithm design techniques. What's the use of this iteration and recursion means? These 2 techniques is used to solve the same thing again and again, or same action these 2 things will do again and again. Understand? But what's the thing you need to remain mean? So even when the action is same, but the state of the action is different. Okay. So for example, So state means immediately you need to remember the example about traffic signal. Okay. So consider in 6th chapter we have studied about traffic signal problem. Okay. So what's the aim of that problem? So there are 3 colors, green color, red color as well as amber color. At a time, so any one color will blink. Isn't it? So any one action will take place. Either green means you need to walk. Red means you need to stop. Isn't it? Likewise, so either green color or red color, the light needs to blink. Isn't it? Just a thing. So either red color means also the light needs to blink. Green color also the light needs to blink. So the action is same only. But the state is different. Understand? So action is same only. The light is blinking. But the state of the action is not same. Because the green color light is blinking means you need to walk. So your action is different. Understand? Next. So if a red color light is blinking means, so you need to stop. So at which stage it is executed, that is not same. But both the what's action, either green color light needs to blink or red color needs to blink. So that is same. But if red color means you need to stop and green color means you need to walk. So the state of the action is different. Understand now? So each time, so the action is take place based on the state. So if the state is changes means the action also change. So the light is green color, till green color, so you need to walk. So after the light blinks to red color, so you need to stop. Understand? Based on the so action, the state become changes. Okay. And also, so the same action, what do you mean by iteration we have studied? The same action is repeated again and again, but in different states. Okay. For example, green color light also blink, red color light also blink. It is a continuous process. The same action is again and again repeating, but in different states. For example, green color 5 minutes, red color 5 minutes. Understand? Each in different states, the action is repeating. Okay. But so if you need to get the proper input-output relation means, so the state, based on the state changes only, you need to get the proper input-output relation. That means till green color is there, you need to walk. Then till red color is there, you need to stop. So that's the input-output relation. So based on the state changes, you will get the input-output relation. Understand? So these are the introduction about iteration and recursion. But what do you mean by iteration? Iteration means same action you are doing repeatedly or again and again. So that is called iteration. For that, 2 designing techniques you are taking. What are they? Iteration as well as recursion. Okay. So even though the action is same, but the state becomes different. Understand? Next, we are going to study about iteration in detail. Okay. So this iteration, so what are the things you have studied? Chapter 6, 7 and 8. So each thing is the basement for the basement from chapter 9. Okay. So from chapter 9 onwards, you are studying a programming language called C. So each things will come in C. Okay. So iteration means, so here you have studied about loop body. Isn't it loop? What do you mean by loop? So you have given some conditions. That conditions will execute. Based on the conditions, the process will execute sometime. That is called as loop, isn't it? So iteration means, so as long as you are going to give some condition. Okay. So you are going to give some condition. So till the loop is executed, the condition becomes true. Understand? For example, the same example, you take traffic signal. So you are giving the condition, the light equal to green. Okay. So you are giving the condition, what condition you are giving? Light equal to green. So for example, the green light will blink till 5 minutes. Understand? So the green light will blink how many minutes? 5 minutes. So 5 minutes, till 5 minutes, the action becomes the same. First minute also the green light will blink. Second minute also green light. third minute also green, fourth minute, fifth minute. Till fifth minute, the green light will blink. So, the loop, you are inside the programming, you are giving the color of the light equal to green. So, till 5 minutes, the same loop, the green color, that loop will execute again and again. So, what's the condition you are giving light equal to green? So, inside you are giving statements, light equal to green means you need to walk or go. Okay. So, if the light equal to green will execute till 5 minutes. Okay. Understand? So, this loop will execute until the condition is true. So, what do you mean by condition is true? So, till 5 minutes, the loop becomes execute again and again. Understand what I mean by loop body? Next thing, so each time, so what are the variables you have declared inside the loop needs to update it. Okay, for example, you have given light equal to green. Consider green is a variable. Okay, so I said 5 minutes the light will bring to green. So 5 minutes, till 5 minutes the variable equal to green. It will check the variable is green or not. Next time green or not. Likewise 5 minutes it will check. Each time you need to update the variables. Okay, so and also next thing, so the property of the variable becomes unchanged. Okay, so till 5 minutes, same example you take, till 5 minutes the light equal to green only. So you have already given 5 minutes light equal to green. But after execution of the loop, so you can't able to change the 5 minutes to 3 minutes. Okay, so that is the property. What's the property? Green color means you need to walk. So you can't able to change the property of the variable while you are executing the loop. Okay, so this unchanging property we are calling as a loop invariant. Understand what I mean by loop invariant? So you are consider one loop. So what do you mean by loop? So based on the conditions, the statements you are given inside the loop will execute. Isn't it? So what do you mean by iteration? The same process is going to execute again and again. So inside the loop, this loop body will execute until the condition is true. So for that only one example I said. So in the traffic signal example, you have given light equal to green. So for 5 minutes. So 5 minutes the light will blink to the green color. So it will execute, the loop will execute till 5 minutes. First minute also it will execute light equal to green. Second minutes also till it will execute like 5 minutes. Already we have given condition equal to 5 minutes. In 6th minute, whether the same loop will execute? No. The condition becomes false in 6th minute. Because already you have mentioned in for 5 minutes only. Understand? So that is called what? A loop iteration. So till it will execute the loop will execute till the condition. What condition you are giving? The condition becomes true. Like till that the loop will execute. And also each time the variables you have given inside the loop need to update it. Okay. So whatever you are updating, the property of the variables don't get changed. Understand? So the what's the mean by property? The green color means you need to walk. So the property you can't able to change. So already you have given for 5 minutes. The light will blink to green color. So the what's the property? You need to walk. So you can't, after execution you can't able to change. The green color means you need to stop. So this unchanging property we are calling as a loop invariant. Okay. This is the loop invariant is very very important technique for designing iterative algorithms. Understand? Very very important question, loop invariant. Understand? So next thing is a recursion. Okay. So recursion also related to iteration. Okay. So recursion also related to iteration. Okay. So here also some problems, some process you are going to execute again and again or repeatedly. Okay. But what's the concept of recursion means? Listen. So in a problem, you are going to solve one problem. Consider one mathematical problem. So in a mathematical problem, they will give lot of inputs. What do you mean by input? Given. So solutions immediately if you are going to start a solution, you will start from first what's the step you will do? Given. So what are the numbers you have given as a, in the question you will write as a given. That is called as input. But recursion, So if you are going to solve one problem, you will take all the given numbers and you will go to solve. Or given expression. For example, in a mathematical problem, they are asked to solve LHS equal to RHS. Understand? At last, you need to prove LHS equal to RHS. First, what part you will take and solve? LHS. Left hand side, you will take the expression and you will solve. Next, you will get one answer. Then, right hand side, you will take and solve. You will get answer. At last, you will compare and both the answers are correct means. So, you will prove LHS equal to RHS. Isn't it? Same thing, recursion means also you are going to solve one problem. Okay, solve one problem with a given input materials. Okay, but the same problem, consider, okay, the same problem. What are the given inputs? Based on that input, you are going to solve the problem. But just say you will get one solution. Same problem, you are going to take part of the input. What do you mean by part of the input means? Consider, in a question they asked to prove LHS equal to RHS. So, first you will take LHS part and you will solve. Isn't it? Then you will get one, so you will find out one solution for LHS. Then only you will solve RHS. Likewise, so if in this recursion means, so they are giving lot of inputs to the problem, but recursion means it will take part of the input. So LHS equal to RHS means you should take first LHS part alone. RHS you are not going to solve at the first. Likewise, recursion means one problem they are giving input, part of the input you are taking to solve the problem. Okay, but using that part of the input you are getting original solution for the problem. By using this partial input, you are getting solution to the original problem. For example, I am telling, in a problem, you are going to add 4 numbers, okay? You are going to add 4 numbers. But what you will do? So, you will add 4 numbers means 4 numbers you will add and get the answer. But recursion means, that's how many inputs are there? 4 numbers means 4 inputs. So, you will take 4 inputs and solve the problem and take the answer. But recursion means, you are not taking the 4 numbers as a input. Among the 4, part of the input. Part means half. Okay. So 4 numbers you are giving as input means 2 numbers it will take as a input. And it will solve the problem. But among the 2 inputs you are getting the original solution for the problem. That is called recursion. Understand what you mean by recursion? So next thing we are going to study about invariance. Okay. So already we have studied loop invariant. Isn't it? What do you mean by loop invariant? So you are going to execute one loop. So the condition becomes true at the starting and end of the loop, as well as you are going to solve the problem by taking the partial input and you will get the output, isn't it? So listen. So here invariant means you are going to solve one problem. Okay. So before solving also you need to get the same answer. After solving the problem also you will get the same answer. So similar to in maths you will prove no LHS equal to RHS. Likewise here also they will give one problem. So you are going to solve the problem. Okay. So before also you will get the same answer. After solving the problem also you will get the same answer. Understand? Now see this example. So suppose read the question. Suppose the following assignment is executed with u comma v. So how many variables they have taken for this problem? 2 variables. What are they? U and v. Okay. So what's the value of u? They have given 20 comma 15. Okay. What's the value of u now? 20. Then what's the value of v now? 15. Okay. We are going to find. So annotate. Annotate means just we need to prove. Like we say LHS equal to RHS in maths you will prove no? Similar. So we are going to annotate. So before and after the assignment. So you are going to assign some values for this problem. But before assignment and after the assignments also, if you get the same answer means you can say this problem is invariant. Understand my point? So you are making some changes by assigning some values. Okay. So after giving assignments also, you will get the same answer before the assignment also you will get same answer. After assigning some values also you will get the same answer. If you get the same answer means you can say this loop is called invariant. Understand? So see this example. So what's the value of u and v? 20, 15. So you need to write this problem as a comments. Already we have studied how you need to write in a specification, isn't it? So specification algorithm also you should write with comments line. Likewise, to comments line always starts with 2 dashes. So before you should write like a before to colon. So before means what values they are given in the question that you need to write. So before u comma v, what's the value of u comma v here? 20, 15. Understand? What value they have given in the question, that value you should write as a before. That means given value. So before u comma v equal to 20, 15. Next you are going to assign some values. Okay, you are going to assign some values. That means, so you are going to change the value of u and v to, listen, u comma v equal to u plus 5. Okay, so you are going to add 5 to the value u. Next, comma, and also you are going to subtract a value 5 from v. Understand? So what modifications you are going to do? So you are going to add a value 5 to the value u, as well as you are going to subtract a value 5 to the value v. Understand? So this is the assignment. Now solve the problem. U plus 5. So what's the value of u here? 20. So 20 plus 5, answer is 25. Then v minus 5. So 15 minus 5. What's the value you will get? 15 minus 5, 10. So this is the value after making the assignment. This is the assigning values. What value you are assigning? Adding 5 to u and subtracting 5 to v. Isn't it? So after you are getting the value 25 comma v. Sorry, 25 comma 10. Now what's the value of u and v? 25 comma 10. So now we are going to check so whether after the assignment and before the assignment we are getting the same values. Understand? So listen. How we are going to check means first you need to add the value before value. So before means given value. So first you need to add the given values 20 plus 15 u plus v. Okay, u plus v. Add it. 20 plus 15, what answer you will get? 35. Next, after value, last answer you will get, no? That answer also you add. 25 plus 10, what answer you are getting? 35. Understand? So before the assignment also, before assigning the value 5 also you are getting the same answer 35. After the assigning some values to this u and v, after also you are getting, after the modifications also you are getting the same answer 35. Understand? Like this, if you get the answer same means you can say this is an invariant. Understand what you mean by invariant? So that only they are telling. So the assignment has not changed the value of u plus v. So you are assigning the value 5 plus 5 to u and minus 5 to v. So after the assignment also the value of the before and after value is not get changed. So we can say this u plus v is an invariant. Understand how we can say this u plus v is an invariant? So after the assignment and before the assignment also you are getting the same answer 35. So we can say this the u plus v is an u and v is an invariant. Understand? So that solution they have given u plus v before the value u plus v you are getting 35. After the assignment, what assignment you are doing? U plus 5 and v minus 5. So after the assignment also you are getting the value 35. So this loop becomes before the loop and after it is true. What do you mean by before? Beginning. That means given value is indeed before. So before also it will true. The answer is true. After the assignment also the answer is true. So like this you will get answers true before and after means you can say this is called invariant. This problem is an invariant. Understand? So if they ask to find the invariant means they asked to prove this problem is invariant or not means you should write the before, then you can write some assigning values, then you can do the after step, then you can compare both the values. If you get the same answer means you can say this problem is invariant. Understand? See next example. So listen. So in this example they have given two variables. What are your variable? P comma C. Okay, so what's the variable there? What's the value? 10 comma 9. Okay, they have given. So before the assignment, question itself game, before the assignment, they have given the value of P comma C is 10 comma 9. But after the assignment, the value you are getting is 11 comma 10. Understand? By question also, the question itself they are given. Before assignment, the value of P and C is 10 comma 9. So after the assignment, the value needs to get is 10 comma 11. Sorry, 11 comma 10. Just a thing in. So if you need to get the 11 comma 10 means you need to add the value to first value 10 plus 1. Next, the same value you need to minus. Sorry, not minus, add only. Okay, 10 plus 1 as well as 9 plus 1 means you can get 11 comma 10. Isn't it? Yes. Listen. So before means what you need to write? The given values of the question. So what the value they have given? Before what the value is P comma C is 10 comma 9. So you need to write the value given in the question. P comma C equal to 10 comma 9. Next you are going to make assignments. So the P comma C you are going to change the value P equal to P plus 1. The value C equal to C plus 1. Understand? The value P is you are going to add the value P plus 1 and C is C plus 1. Okay. So after what's the value you will get? P plus 1 means 10 plus 1. 10 plus 1 means what answer you will get? 11. Then 9 plus 1 means what answer you will get? 10. Okay. Next we are going to check whether before and after the assignment you are getting same values. Anyway you need to get the same answer. So last problem you will add, isn't it? So you have to add two numbers. Last problem U plus V, isn't it? You had been add two numbers. Here if you need to get the same answer, what do you need to do? You are going to subtract. Just you need to think and do it. Okay. So how you need to make the answers before and after assignment as the same. So you need to think it and do. What's the step you need to do? So here before the assignment you are going to subtract the value P minus C. Okay. So what's the before the assignment? Before assignment what's the value of P and C? 10. So 10 minus 9. 10 minus 9 what answer you will get? 1. So after the assignment what value you are getting? 11 comma 10. So subtract it 11 minus 10, 1. So P minus C, what answer you are getting? 1. So both before the assignment also you are getting the value P minus C 1. The after the assignment also you are getting P minus C equal to 1. So we can say this problem is an invariant. Understand why we are saying the problem is an invariant? Before the assignment also you are getting the same answer. After the assignment also you are getting the same answer, but you are subtracted here. Last problem you had, but here you are subtracted. Understand? Next, listen. So here already we have studied whatever changes you are making before and after the assignment, the variables becomes the same value. Okay. So in expression, so variables has the same value before and after the assignment, isn't it? So here there also P and C you are getting the same value as a 1. Then there also you are getting U plus V. First question you are getting U plus V equal to 35. The second question you have studied P minus C you are getting the variables P and C you are getting the answer as a 1. So we are saying before and after the assignment this problem is a invariant. Now we are going to assign some variables for this problem. Okay, listen. How you are, but in problem they will give P of U comma V, isn't it? U comma V they will give some values. So here what are the variables? U and V. What are the name of the variables? U and V. So they have given this is an expression. P of U comma V is an expression. So this expression will contain two variables U and V. Understand? Listen. So you are going to assigning two variables E1 and E2. Okay. So you are going to replace the U and V value by E1 and E2. Understand? So you are going to replace the value of P of U comma V. You are going to replace the value of U and V to two values E1 and E2. Substitute here P of U comma into So P of u comma into, this is a format, u comma v, you are going to change E1 comma E2. Okay, this u comma v are going to change E1 comma E2. So how you will get the answer of P of u comma v? By replacing the values of u and v to E1 and E2. Okay, now you are going to prove that this one E1 and E2 by invariant or not. Okay, so listen. So what's the question? P of u comma v is an invariant of the assignment. What value you are going to change? U and v to E1 and E2. Substitute here. So P of u comma v equal to, so u comma v you are going to change E1 comma E2. Okay, so after assigning these values also you need to get the answer P of u comma v. Then only you can say the value is an invariant. Isn't it? When you will say invariant, so before you what's the value they have given in the question, P of u comma v. But after assigning you are changing this u comma v to two values E1 and E2. But after the assignment also you need to get the same answer P of u comma v. Then we can say this loop is called invariant. Understand? So by substituting the values, like we said last slide we have study E1 and E2, the same format you are going to prove. So P minus C is an invariant. Already you have studied about invariant, the same problem we have proved. But now using this assignment of two values E1 and E2, like the same format you are going to prove this P minus C is an invariant. Understand? So in this question what you are going to prove? P minus C is an invariant. Okay. So listen. First you are going to assign the value. So in last slide we have studied P of u comma v equal to P of the u and v, you are going to change E1 and E2 to different values. Likewise we are going to substitute the value of P and C to P plus 1 and C plus 1. Understand? So you are going to, what's the expression? P of P comma C. What you need to prove? P minus C is an invariant. That means P minus C is an invariant. You need to, at last you need to get the answer P minus C. Okay. So for that, like a probability you will take P of N, P of likewise. So here the two what are the variables? P and C. You are going to change the value of P to P plus 1 and C to C plus 1. So in the place of P you need to substitute the value P plus 1 and in the place of C you need to substitute the value C plus 1. Okay. So listen, this is the question. This one you need to prove. P of P comma C equal to P minus C. Okay, what you need to prove? P of P comma C equal to P minus C. This one you need to prove. Okay. Now substitute. So what's the problem? P of P comma C. P of P comma C. So inside the bracket, listen, this value you are taking P comma C. So what's the value P comma C? So P comma C means the P value is changed to P plus 1. Please listen carefully. We are taking the probability, that means P of P comma C. Okay, only we are taking left hand side, but you are going to prove the answer as a right hand side. RHS. Okay, so P of P comma C. Listen, in these two variables you are taking. Okay, this is the P of a probability of this whole thing you are going to prove as a P minus C. So P of P comma C means P comma C, the value of P comma C you are changing to P, you are going to change this P plus 1. Comma C you are going to change this C plus 1. Understand? Now substitute. So P of P comma C, what value they have given? P minus C. So substitute here. P of P comma C means what value they have given? P minus C. Okay. Then inside P comma C equal to P plus 1 comma C plus 1. Okay. Just leave it this part. Just only listen. P minus C. P minus C. So what's the value of P now? P plus 1. So P minus C. Substitute the values here. P minus C means P plus 1. So P value is now P plus 1 minus C value is C plus 1. Understand? First you are substituting the value here. P of P minus C means P comma C means P minus C. Okay. So now what's the value of P now? P plus 1. What's the value of C now? C plus 1. Now substitute the values here. What the value of P? P plus 1. So P plus 1. This minus, what's the value of C? c plus 1. Understand? Now remove the bracket. So here one step will come. P plus 1 minus. So before the bracket minus will be there means minus c minus 1. So plus 1 and minus 1 will get cancelled. Remaining thing p minus c will be there. So what's the question you need to prove? P minus c. So how we get the answer p minus c? So you will get the answer as a p minus c. In question also they have asked to prove p minus c is an invariant. Understand? So once more I am explaining. So here in question they asked to prove p minus c is an invariant. But for that you are going to assign the value p as a changing the value p to p plus 1 and c to c plus 1. Okay. So what's this one? You are going to take let p of p comma c to p minus c. Okay. So here substitute the values p of p comma c. So p and c are going to change p plus 1 comma c plus 1. Now substitute the value p of p comma c. What's the value of p of p comma c? P minus c. So this value, now what's the value of p now? P plus 1 and what's the value of c now? C plus 1. Substitute the values here p minus c. Value of p is p plus 1 minus value of c is c plus 1. Now remove the bracket p plus 1 minus c minus 1. So plus 1 and minus 1 get cancelled. Remaining answer you are getting as p minus c. So you are p minus c means p of p comma c. So in the question itself they asked to prove p minus c. Okay. So if you are changing the values also you are getting the answer p minus c. So we can say this is an invariant. Understand? So same format the next question. Okay. Same format when you are going to solve the next question. So in this question you are consider two variables m and n. So what are the variables name? M and n. Okay. So here what value you are going to assign means m in the place of m you are going to change the value as m plus 3. What's the value of m now? M plus 3. Then what's the value of n now? N minus 1. So here in question you are going to check m plus 3n is an invariant. Okay. So what you need to prove? M plus 3n. Last question we have solved. M p minus c is an invariant. Likewise here m plus 3n is an invariant or not you are going to check. So what you need to prove? P of m comma n equal to m plus 3n. Okay. Now substitute the values like a last problem similar. What you need to write first? P of m comma n. So what are the variables? M comma n. So m comma n means already you have substituted already you have given the values. M is changed to m plus 3 comma n is changed to n minus 1. Understand? First step you should write like this. Okay. P of m comma n. Then given values. What's the given values? The m comma n equal to m value is m plus 3. Then n value is n comma 1. Sorry, n minus 1. Okay. Next step. P of m comma n is what's the value of p of m comma n? M plus 3n. Okay. M plus 3n. So substitute here m plus 3n in the place of p of m comma n substitute m plus 3n. Remaining things like this. Okay. M comma n is m plus 3 comma n minus 1. Now listen. M plus 3n. So what's the value of m now? M plus 3. Substitute here. What's the value of m now? M plus 3 plus 3n. So 3 into n. So what's the value of n now? N minus 1. So 3 into here. Substituting the values of m and n to this m plus 3n. What's the value of n now? N minus 1. So 3 into n minus 1. Understand? First substitute the value of m here. What's the value of m? M plus 3 plus 3 into n. What's the value of n now? N minus 1. So 3 into n minus 1. Understand? Now multiply. So here m plus 3 plus, remove the bracket, m plus 3 plus, multiply 3 into n, 3n. Then plus 3 into minus 1, minus 3. Okay. Then plus 3 and minus 3 get cancelled. Remaining answer you are getting as a m plus 3n. Understand? In question what they asked you to prove? P of m comma n equal to m plus 3n. Now m plus 3n means the value you can write p of m comma n. Okay. So now you can prove the what question they have given. So you need to prove p of m comma n equal to m plus 3n. You'll get the answer. Understand? So first you need to write the given values like this, p of m comma n, then given values. In the place of p of m comma n, you should substitute p m plus 3n, then substitute the values of m and n. What's value of m here? M plus 3, then plus 3 into, what's value of n here? N minus 1. Then remove the bracket and multiply. The plus 3 and minus 3 get cancelled. Answer you will getting as m plus 3n. Understand? Now we can say this problem is an invariant. So likewise they will ask own problems also. Likewise you need to make some assignments and you need to bring the answer. Understand? Next thing is a loop invariant. Okay, loop invariant. When we can say the loop is invariant. Okay, when we can say the loop is invariant. So the loop invariant, the loop body. So inside the statements we are given, no, that we are calling as a loop body. So here what are the things you need to remember means loop invariant means you need to know about loop body. Okay, what do you mean by loop body means? So we are given one condition. Okay, if you give one condition, so based on the condition, the loop body will execute. For example, the traffic signal problem. So what's the condition? If signal equal to green, that's the condition. So that's the condition means what are the things you are given inside green means you need to walk. So that's the loop body. Understand? Condition is green. So you are giving the condition is green means you need the statements you are giving is walk. Understand? So likewise, when we are saying this loop invariant means read, L is an invariant of the loop body. Which one is invariant they have given? L. If we say this L is an invariant, when we can say the loop body, L is an invariant of the loop body with, when we can say this L is an loop invariant, with the loop body. Okay. So, what are the conditions you need to find, and that is the important thing. What are things you need to note when the loop is invariant? Okay, what are things you need to note when the loop is invariant? Okay, so listen. So, the loop becomes true before the loop body. Okay, before the loop body and after the loop body, the loop becomes true. Understand? Before the loop body and after the loop body, the loop becomes true. Okay, so that's the first condition. Next condition. So this L is true start of the iteration as well as start of the loop. Okay, that's the second point. Then L is true at the end of the last iteration and end of the loop. Okay, 4 things you have study. This L is true when becomes true. So for example, in that problem, before starting of the problem, before the assignment also, for example, in the problem we have given no P minus C. That's the before assignment. That is the before also true. Then last problem, at last you will solve and take the answer P minus C. So before also true, last also true. So first iteration, first you are going to substitute P minus C. That's the first iteration. So first iteration also it will true. Then last you are taking the answer P minus C. That's the last iteration. That also true. Understand now? So when becomes the loop invariant become true? 4 things. Very, very important. Before the loop body, when it needs to true. Before the loop body it needs to true. After the loop body also it needs to true. Before the loop body true, then after the loop body. And first iteration also it becomes true. And last iteration also it becomes true. Then starting of the loop it becomes true. And ending of the loop it becomes true. Understand? Very, very important. So, the same thing we have studied, no? So, when we become the loop is invariant, loop we have denoted at the letter L. When becomes it will true? Starting of the loop, just before the loop. That means starting of the loop it will becomes true. Then, before the loop body, before of each iteration. Start of the loop, then each iteration, then end of each iteration, end of the loop. This 4 very, very important question. When becomes the loop invariant? Becomes true. When start of the loop, then start of each iteration, end of each iteration and end of the loop. Okay, same thing you are going to write in algorithm. Listen, the L is becomes true, start of the loop, then condition. We are giving one condition, then start of, first start of the loop, then condition, then start of iteration, then loop body, then end of iteration, then end of the loop. This one you need to study. Okay. Same thing you have mentioned in flowchart. Listen. So inputs, you have given inputs. Okay. So input as a, this is the input as a start of the loop. You are going to start the loop. So input 2 variables or 3 variables you are giving as a input. Then you are giving some condition. Okay. Then so after the condition the loop body will execute. Then output. So when becomes the condition become true, listen, starting of the loop after giving the input. Input for example u comma b 10 comma 15. So this input also the loop becomes true, start of the loop. Then giving condition. This is the iteration. So here also the loop becomes true. Then the loop body. Here also the loop becomes true. Then the end of the iteration and end of the loop. Here also the loop becomes true. Very very important loop invariant. If they ask means you need to write the definition. Then syntax this flowchart. Very very important. Okay. So time over students. Today's class over. Remaining things we can continue in the next class. So after completion of this session, please study this loop invariant as well as 3 problems I have taught. So you should study these 3 problems and write in your paper or computer notebook. Very very important. Thank you students. Thank you. We can continue in the next class. Okay.